Alright, in this video I'm going to show you how to rationalize denominator other than a square root. So when you have a square root, let's take an example. 1 over the square root of 2. Because the denominator is a square root, so all we need to do to rationalize is to multiply the top and the bottom by the same denominator, which is the square root of 2. So when we do, we have root 2 over 2. Now you can see that we have rationalized by getting rid of this radical on the denominator, and that is the whole idea of rationalizing. But when we have a denominator other than a square root, if we apply that method, it's not gonna work. Alright, so I'm gonna show you how to rationalize when you have a denominator other than a square root. But before we can do that, let's just see the reason why it works for the square root. If we have the square root of a over the square root of b, now if we use the same logic by multiplying the top by the same denominator, which is the square root of b, we're gonna have the square root of a b over the square root of b to the first power, and this denominator to the first power is crucial when we use that method. Alright, so what we're gonna do, we're gonna use this simple formula here to transform the radical into its rational exponent form. Alright, to make that clear, let's take the same example again. We have the square root of a over the square root of b. Now the square root, the 2 is not usually written, but it's understood to be there, so there is a 2 there, and the a is raised to the first power. Square root, there is a 2, and the b is raised to the first power. Now to change this to its rational exponent form, it's going to give us a to the 1/2 over b to the 1/2. Now using the same logic again, we multiply the top and the bottom by the same denominator, which is b to the 1/2 over b to the 1/2. Now when we do that, we're going to have a to the 1/2, b to the 1/2 over b to the first power. Okay, because when we multiply exponent, if the bases are the same, we keep the base and add the exponent. So we're going to keep the base and add the exponent. 1/2 plus 1/2 will give us b to the first power. Like I said, this is crucial. Alright, so now we're going to transform this to its rational exponent form in order to use the method where we have to multiply the top and the bottom by the same denominator. Alright, so let's take this example. Now we have 4 over the cube root of 6. Now we're going to change that to its rational exponent form. That's going to give us 4 over 6 to the 1/3. Now here is where we need to do a little bit of thinking. Now we need to think what we're going to multiply by 6 to the 1/3 to get 6 raised to the first power, and that's going to be 6 to the 2/3. Now this is what we're going to take now and multiply it, the top and the bottom. So we're going to have 4 over 6 to the 1/3, and then we're going to multiply the top and the bottom by what we just worked out here, which is 6 to the 2/3. So 6 to the 2/3, 6 to the 2/3. Now so we multiply the top, we have 4 multiplied by 6 to the 2/3 over 6 to the 1/3 multiplied by 6 to the 2/3. Like I said earlier on, we multiply in exponents, the bases are the same, so we keep the base and then add the exponent. When we add 1/3 to 2/3, that's going to give us 1, so we have 6 raised to the first power. Okay, so now all we need to do is just to transform this back to its radical form, and that's going to be 4 multiplied by the cube root of 6 square, which is 36. All of that divided by 6. So we simplify, 2 goes 2 times into 6 3 times. So our final answer is gonna be 2 the cube root of 36 over 3. So I hope this is helpful. Thank you.